Welcome my dear learners for this course on mechanical vibrations. In this module 2 we were discussing on forced vibration and vibration measuring instruments. So far we have started discussion on numerical problems on forced vibration system analysis, and we have completed our discussion on forced vibration systems subject for harmonic excitation, reciprocating and rotating unbalance. Moving ahead, continuing from the point where we have stopped in our previous lecture, in today's lecture I am taking up numerical problems on support motion, the expressions of which we have already discussed during our discussion on derivations of amplitude ratio for support motion. Now I am discussing the solution for the question bank, which I have attached through the link given in the description. Kindly click on the link given below this video in the description to get access to the question bank. For that question bank we are discussing the solution in this lecture series. Now moving ahead, the problem number 7 states that the spring of an automobile trailer are compressed 0.1 meter under its own weight. Find the critical speed when the trailer is passing over a road with a profile of sine wave whose amplitude is 80 millimeters and the wavelength is 14 meters. Find the amplitude of vibration at a speed of 60 km per hour. Now if I move for solution of problem number 7, if I list out the data given, the problem is based on an automobile trailer. The problem is based on automobile trailer subjected for forced vibration due to irregularities present in the road. So the vibration of automobile is excited because of the irregularities present in the road. So this problem is based on absolute motion. This problem is based on absolute motion, because the vibration of the automobile trailer is measured with reference to fixed reference, because the earth is not vibrating, correct? It has irregularities in it. The profile of the irregularity in the road is sinusoidal wave profile. It is not vibrating, it is fixed. The amplitude of that sine wave irregularity is 80 millimeters, and the automobile trailer will be subjected for vibration. The vibration of automobile trailer is measured with reference to fixed reference, that is with reference to earth, that is on the road. So therefore this problem is on absolute motion. Kindly make a note of it. Now for absolute motion we have derived the expression for amplitude ratio, that is A by B is equal to square root of 1 plus 2 zeta omega by omega n whole square divided by square root of 1 minus omega by omega n whole square plus 2 zeta omega by omega n whole square. Hope you people remember that, because we have already recollected the formulas what we have derived so far in our first lecture of problems. That is, when I solved problem number 1 of our discussion on vibration, forced vibration, I recollected the formulas which we have derived. Hope you people remember all the formulas. Let us move ahead. The automobile trailer is compressed by 0.1 meter. So due to its own weight it is compressed. So static deflection is 0.1 meter because it is compressed under its own weight. It is static deflection. Find the critical speed. So that is, find the critical speed. So critical speed is the speed at resonance at omega is equal to omega n. When the trailer is passing over a road with a profile of sine wave whose amplitude is 80 millimeters, the amplitude of the road is given, the amplitude of base is 80 mm, that is B, which is given by 0.08 meters. In the amplitude ratio A by B, A is the amplitude of vibration of the vibrating body, B is the amplitude of excitation. Here amplitude of excitation is B, that is irregularity of the road, which is 80 millimeters, and the wavelength is specified. Wavelength is 14 meters. Find the amplitude of vibration of vibrating body, that is A, that is find the amplitude of vibration of automobile trailer at a speed of, yes, specified the speed, so at a speed of 60 km per hour. at a speed of 60 km per hour. Now let us solve this problem. Now moving ahead, here the automobile is not rotating, correct? The automobile is moving forward. The motion of automobile is linear in nature, it is not rotary in nature. So therefore the critical speed what we will find for automobile will be velocity of the automobile, that is v, that is not n, because automobile is not rotating, it is making a linear motion, correct? So therefore I should find velocity of the automobile, critical speed of automobile. Now if I move ahead for solution of this problem, we have the static deflection is given, so therefore omega n can be determined by using static deflection as root of g by delta. So square root of g is 9.81 divided by delta is 0.1, hence the natural frequency is 9.9045 radians per second. Now we know the wavelength, we want to find the critical speed, and we know the natural frequency. So since natural frequency is known, I can find the frequency in hertz. Fn will be what? Omega n by 2 pi. So this divided by 2 pi will be 1.567 or 1.576 hertz or cycles per second. Hertz is also known as what? Cycles per second. So 1.576 cycles per second. You people already know the relationship between frequency in cycles per second and wavelength and velocity. What is the relationship between velocity, wavelength and cycles per second? That is cycles per second, frequency cycles per second is equal to velocity divided by wavelength. So this is the relationship between frequency, velocity and wavelength. Kindly make a note. Now I should find what is the critical velocity of the automobile at which resonance occurs. So now to find the critical velocity of the automobile at resonance, omega is equal to omega n, correct? So therefore at resonance, at resonance frequency will become natural frequency. So therefore I know natural frequency, I know wavelength is 14 meters, so therefore I can find the critical speed, correct? So therefore A, how much is the critical speed? So critical speed will become F is how much? 1.576 into wavelength is 14 meters. So how much is that? 14 into 1.576, which is 22.064 meters per second. Always we express the speed of automobiles in kilometer per hour. So therefore it is a good habit to mention the velocity in kilometer per hour. Hence mention the critical speed in kmph, kilometer per hour. That is 22.64 into 18 by 5. Correct? 18 by 5 is the conversion from meter per second to kilometer per hour, which is nothing but 3600 divided by 1000 into 18 by 5 is how much? 79.43 kilometer per hour. So if this automobile moves at a speed of 79.43 kilometers per hour, at that speed resonance will be occurring. That is, the automobile will vibrate with the maximum amplitude. So one question is done. Next I want to find the amplitude of vibration, correct? When the vehicle moves at a speed of 60 km per hour, right? So when vehicle moves at 60 km per hour, find what is the frequency. Now second one, to find amplitude of vibration when vehicles moves at 60 km per hour at v is equal to 60 km per hour, find the value of omega. that is, we already know that V is equal to F into lambda, hence F will become V by lambda. V is how much? Convert this into meters, that is 60 into 5 by 80, because from meter per second to kilometer per hour it is 18 by 5, from kilometer per hour to meter per second is 5 by 18. 5 by 18 divided by lambda. Lambda is how much? 14. So this is to convert from kilometer per hour to meter per second. Kindly make a note. So hence, how much is the frequency in cycles per second? It is 60 into 5 divided by 18 into 14, which is 1.19 hertz or cycles per second. So therefore, how much is omega? Omega is 2 pi f, which is into 2 into pi, which is turning out to be 7.48 radian per second. Now we know omega n, we know omega, so I can find the value of omega by omega n ratio. How much is omega by omega n? It is 7.48 divided by 9.9045, which is nothing but 0.7552. Now if you carefully observe, he has not specified anything about dashpot or damper. Now recollecting the formula of amplitude ratio for absolute motion. For absolute motion, if I recall the amplitude ratio formula, we know that for absolute motion, A by B is given by root of 1 plus 2 zeta omega by omega n whole square divided by root of 1 minus omega by omega n whole square plus 2 zeta omega by omega n whole square. Clear? So since it is not specified anything about dashpot, zeta should be 0. It is undamped. So these two will get vanished. Now the equation will boils down to be A by B is equal to 1 divided by 1 minus omega by omega n whole square. 1 divided by omega by omega n whole square. Here I want to make a very important note. Whenever the value of omega by omega n is greater than 1 or A by B is less than 1, that is, if omega by omega n is greater than 1 or A by B is less than 1, or the value of B is greater than A. Whenever any one among these three is satisfied, always rewrite this equation in this form. Always take, very important note, always take A by B ratio as 1 divided by omega by omega n whole square minus 1. Kindly consider it like this. This is because of the reason, otherwise you will get the negative answers is the one thing. Whenever you want to find omega by omega n ratio by knowing A by B, in which B is greater than A, you will end up with imaginary answers. So in order to avoid these two conditions, you should always rewrite this equation like this, only for undamped vibration analysis, undamped forced vibration analysis, because here the value of zeta is 0. Here he has not specified anything about damping. So therefore zeta is 0. There is an undamped forced vibration analysis. In undamped forced vibration analysis, the actual equation will boils down to this one. We can't use this one directly. We should inspect it properly. What is the inspection required? Check whether omega by omega n is less than 1. It is less than 1, done, good and fine. Move for a by b. Check whether a by b ratio is greater than 1. Else you change this equation like this. Or else you check whether b is greater than a. If b is greater than a also, you change the equation. Otherwise, if a itself is greater than b, no worries, this equation prevails. So now if I observe none of this is satisfying, therefore this equation itself will satisfy, because omega by omega n is not greater than 1. How much we got? Omega by omega n is 0.7552. No need to worry, because omega by omega n is less than 1. No worries, I can use this equation itself. So this will become an important note. Let us see whether we encounter this in our next problem or not. So this is a very, very important note. Kindly make a note of it. So for this problem, no worries, because we are not getting any of these conditions. So use this equation and find what is the value of A. What is the value of A? B is known. B is 0.08 into 1 minus 0.7552 square inverse, because I am taking it to numerator, right? So hence I will get the value of A. So how much is the amplitude of vibration? It is 0.08 divided by 1 minus 0.7552 square. So the answer is 0.18618. So is given in millimeters. Let me write the answer also in millimeters. It is 186.2 millimeters. It is 186.2 millimeters. The answer what I got is 0.1862 meters. I converted this into millimeters. This is because I specified the excitation in millimeter, therefore I will give him the value of vibration amplitude also in millimeters. So this is solution for problem number 7. So this is solution for problem number 7. Let us move on for problem number 8. Now moving ahead for problem number 8, which states that a vehicle of mass 490 kg and total spring constant of its suspension system is 60 into 10 to the power of 3 Newton per meter. Let me list out the data given for problem number 8. A vehicle of mass 490 kg and total spring constant of the suspension is turning out to be 60 into 10 to the power of 3 Newton per meter. The profile of the road may be approximated as a line curve of amplitude. So road amplitude is given, which is B, which is 4 centimeters, which is nothing but 0.04 meters. For a wavelength of 4 meter, determine A, critical speed of vehicle. Find the velocity of vehicle at resonance, because critical speed is the speed at resonance. The amplitude of the steady state motion, of mass when the vehicle is driven at critical speed at VC, which means what? It is nothing but, he is asking us to find at resonance, which is nothing but the maximum amplitude of vibration. Next, C. Oh, here he is also specifying the damping factor, right? And the damping factor zeta should be taken as 0.5. And C, the amplitude of steady state motion of the mass when the vehicle is driven at a speed of 57 km per hour. And the damping factor is same as case P, that is 0.5. Let us solve this problem. If I move for solution, Let us solve this problem. So case A is same as what we have done, right? VC, same thing you repeat. So see here is given mass and stiffness. So therefore omega n should be what? Omega n should be root of k by m, because here is not specified the static deflection. So hence if I substitute and solve, how much I will get? It is square root of k is 60 into 10 to the power of 3 divided by mass is 490. Hence the natural frequency is turning out to be 11.066 radians per second. But I have the relationship between wavelength, velocity and hertz, cycles per second. Hence convert this into cycles per second. So how much is Fn? Fn is omega n by 2 pi, which will be this answer divided by 2 into pi, which is nothing but 1.761 hertz or cycles per second. Now at resonance, F must be equal to Fn, right? We know that cycles per second is equal to velocity by wavelength. So therefore I can find the value of Vc. So hence critical speed will become what? F into lambda. We know the value of F. How much is F? F is 1.761. So therefore it is 1.761 into wavelength, lambda is 4 meters. Hence I will get the critical speed for this problem as 1.761 into 4, which is 7.045 meters per second. Convert this into kilometer per hour. So if I convert this into kilometer per hour, how much I will get? Vc is equal to 7.045 into 18 by 5. How much is that? Into 18 by 5, which is 25.36 kilometer per hour. 25.36 kilometer per hour is the critical speed of this automobile. Now moving ahead for case B. In case B, we want to find A at resonance, correct? We know that for automobiles, that is for absolute motion, A by B is given by root of 1 plus 2 zeta omega by omega n whole square divided by square root of 1 minus omega by omega n whole square plus 2 zeta omega by omega n whole square, right? At resonance, omega is equal to omega n. So at resonance omega is equal to omega n. Omega is equal to omega n. Hence A will become B into, this is 1, so therefore I left out with root of 1 plus 2 zeta divided by square root of this will be vanished, right? 1 minus 1 is 0. This will be 1. Root and square root get cancels. It is 2 zeta. Correct? So therefore, if I substitute the values and solve, how much I will get A? So if I substitute and solve, I will get the value of A as B is 0.04 meters into square root of 1 plus 2 into zeta. Zeta is 0.5 divided by 2 zeta. 2 into 0.5. Hence the amplitude of vibration is turning out to be 0.05656 meters. So as given in centimeters, hence it is 5.656 centimeters. Next move for C. For C, he has given the velocity as 57 km per hour. So now we know that V is equal to F into lambda, correct? So I want F, so therefore F is equal to V is how much? 57 into 5 by 18. This is very important because 57 is in kilometer per hour. I should always use in meters per second. 5 by 18 meters per second divided by lambda. Lambda is 4. So hence how much is the frequency? Excitation frequency will be 57 into 5 by 18 divided by 4, which is nothing but 3.958 hertz or cycles per second. Hence I can find the value of omega, which is 2 pi of this into 2 into pi, which is turning out to be 24.87 radians per second. Now I can find the value of omega by omega n for simplicity. Omega n is 11.066, omega is 24.87, omega n is 11.066, will turn out to be 2.2474. Now we know all the values. Substitute the values in the equation. A by B is equal to root of 1 plus 2 zeta omega by omega n whole square divided by root of 1 minus omega by omega n whole square plus 2 zeta omega by omega n whole square. So hence how much is the value of A for case C? It is B into B is how much? 0.04 into root of 1 plus 2 into zeta is how much? 0.5 into omega by omega n is 2.2474 square divided by root of 1 minus 2.2474 square whole square plus 2 into zeta is 0.5 into ratio is 2.2474 whole square. If I solve, I will get the answer as 0.02124 meters. 0.02124 meters. You can see here. So this is the amplitude of vibration at 57 km per hour. This velocity is greater than resonant speed. What is the resonant speed? Resonant speed is 25.36 km per hour, whereas this velocity is greater than 25.36 km per hour. But at resonance, the amplitude of vibration must be maximum. You can see that amplitude of vibration is higher. It is 5.6 centimeters, whereas here it is 2.1 centimeters. Even though the velocity is much higher than the critical velocity, that is speed at resonance. Speed at resonance is just 25 km per hour, but the vehicle is moving at a speed of 57 km per hour. Even then the amplitude of vibration is less, but at resonance the amplitude of vibration is high. So hope this problem is clearly telling the difference between critical speed and resonant amplitude. Both are completely different. At resonance, amplitude is maximum, not the velocity. So velocity at resonance is termed as critical velocity. It is not the maximum velocity of the vehicle. Kindly make a note. So this problem clearly differentiates between the critical speed and resonant amplitude. Let me pause this video for a while so that you people can copy it down. Later I will address problem number 9. Now moving ahead for problem number 9 of our discussion. we are discussing the solution for the question bank which I have attached to the link given in the description. Kindly click on the link given in the description below this video to get access to the question bank. For that question bank, we are discussing the solution in this lecture series. Moving ahead, the problem number 9 of our discussion states that a mass weighing 1.93 kg, there is a mass weighing 1.93 kg is suspended in a box by a vertical spring whose spring stiffness is given by 10 into 10 to the power of 3, which is nothing but 10 to the power of 4 Newton per meter. The box is placed on the top of a shake table. It is placed on the top of a shake table, producing an vibration of x is equal to 0.09 sin 8t. Find the absolute amplitude of mass. Find the absolute amplitude of mass. Let us solve this problem. He has also specified that assume no damping. So he has also specified that assume no damping. Take zeta is equal to 0. Take zeta is equal to 0. Now, if you carefully observe, the spring mass system is placed above the shake table, correct? Which is similar to somewhat the vibration measuring instrument. This is because of the reason the spring mass system is placed on the table which is shaking. Then the vibration amplitude measured by this spring mass system is measured with reference to vibrating object which is already vibrating. So therefore, whatever amplitude indicated by this will be relative in nature. This is because of the reason it is mounted on a shaking table. Unless the case of automobile. Automobile is vibrating but it is moving on a road which is fixed. Therefore, it is absolute motion. Here the spring mass system is vibrating. It is mounted on a shake table. The table is also vibrating. So therefore, the vibration of the shake table is absolute in nature because shake table vibration is measured with reference to the fixed plane, with reference to the earth, correct? So therefore, shake table amplitude is absolute in nature, whereas the spring mass amplitude is relative in nature because it is measured with reference to shake table which is shaking. So hence, this is a case of relative motion. Very, very important. Don't get confused. This is a case of relative motion. This is a case of relative motion. Clear? Now, the absolute motion of the base excitation is already known. So, comparing it with the standard excitation equation, x is equal to what we have for base, b sin omega t, correct? So, what is the value of b now? B is 0.09 and omega is 8 radians per second. So since he has not specified what is the unit of amplitude, let me take it as unit itself, 0.09 units. It might be meter or millimeter or centimeter. He has not specified for us. Next, moving ahead, what I can do now, I can recollect recall the equation which we have derived for amplitude ratio for relative motion condition. For relative motion, we have the amplitude ratio equation for relative motion is given by z by b is equal to omega by omega n whole square divided by root of 1 minus omega by omega n whole square plus 2 zeta omega by omega n whole square. So this is the equation what we have. Now omega is already known. It is 8 radians per second. And we know mass and k. So therefore natural frequency can also be determined. How much is omega n is equal to root of k by m. So therefore k is 10 to the power of 4, m is 1.93. Hence natural frequency is 71.98 radians per second. So now I can find the value of omega by omega n. So therefore, what is the value of omega by omega n? Omega by omega n will become 8 by 71.98, which is turning out to be 0.11114. 0.11114. Now zeta is 0, so therefore the equation will boils down to be z by b is equal to 0.11114 square divided by square and square root will get cancelled, 1 minus 0.11114 square. Now if you carefully observe, omega by omega n is not greater than 1. It is not greater than 1. So therefore the equation itself will holds good. No need to interchange the terms. No need to interchange these two. No worries. So now what you will get? The value of z, relative displacement, correct? This is known as what? Relative amplitude. Relative amplitude, z will be how much? B into that one. How much is b? B is 0.09 into 0.11114 square divided by 1 minus 0.11114 square. How much you will get? You get the value of z as 1.126 mm or units. If I take this in meters, this will be in millimeters. So it is turning out to be 10 to the power of minus 3 units. So that is what I got. But what he has asked is the absolute amplitude, correct? But what we require is absolute amplitude. How to find absolute amplitude A? Yes, people already know that relative amplitude is nothing but the vectorial difference of absolute amplitudes, that is amplitude A minus amplitude B. So this you people already know. You know that the relative displacement is nothing but vectorial difference of absolute displacements. Hence the value of absolute displacement A will become what? A is equal to z plus b. Hence A is equal to 1.126 into 10 to the power of minus 3 plus the value of b is 0.09. Hence I will get the value of A as plus 0.09, which is nothing but 0.0911. So this is the solution for problem number 9. So in this lecture we have discussed the numerical problems on support motion, that is amplitude ratio for two absolute displacements A by B and amplitude ratio equation for relative and absolute displacement Z by B. So thereby we have completed the discussion on support motion. Under support motion, the relative amplitudes Z by B is very important in the case of vibration measuring instruments, because vibration measuring instrument is placed on a vibrating body. So the vibrating measuring instruments will also record the displacement amplitude of vibration, but with reference to vibrating body which is also vibrating. Hence whatever the vibrating measuring instruments records will be relative in nature. So therefore under under support motion, the relative motion analysis is very important for design of measuring instruments, vibration measuring instruments, which are termed as seismic devices. That I will take in the later part of this module. In our next lecture I will take up the another concept which we have discussed in our theory during our theory, that is force transmissibility ratio. Let us take up transmissibility ratio problems in our next lecture. That's all from this lecture. Thank you all.